Alright, here we go on the second page. Number 12, trying to determine if they're inverses, we have to verify that f of g of x equals x and that g of f of x equals x. So we'll start with f of g of x. So g of x is x minus 5 over 2.
Yeah.
So I'm going to plug that into the f function. So the f function says to take 2 times that input plus 5. So 2 times this fraction of the denominator 2, the 2's will cancel, giving us x minus 5 plus 5, which does in fact equal x. So I should put a little check mark. That part worked. So then I have to verify that g of f of x also equals x. If this happens, then I will have verified that they were in fact inverses. So f of x is 2x plus 5. So 2x plus 5 goes in the numerator. I subtract 5 from that, and it's all over 2. 2x plus 5 minus 5 is 2x. And 2x over 2 is x. They both worked. Yes, I verified that they are inverses. So then I move on to number 13. F of g of x. G of x is 1/8 x plus 5/4. So plug that into your f function. So 8 times that. Minus 10.
Can I just take this? Thanks.
Distribute. You get x plus 10 minus 10. It does in fact equal x. That worked out. Check mark. So then I'll do g of f of x. F of x being x minus 10. 8x minus 10. Plug that into the g. So distribute that, I get x minus 10/8, which is 5/4, plus 5/4 does in fact equal x, equals x, sorry. Check that one worked. So they both worked. So then I move on to number 14. We're supposed to graph. So we're looking here. We have an h value of -2. Start with -2, plug it in. -2 plus 2 is 0, square root of 0 is 0. Plug in then -1. -1 plus 2 is 1, square root of that is 1. And then we plug in 2. 2 plus 2 is 4, square root of that is 2. So -2, 0. -1, 1. 2, 2. This is an endpoint, so don't put an arrow there. Start there. Travel through those. Transformations, well, the whole thing shifted left too. Domain, x had to be greater than or equal to that -2. Range, y had to be greater than or equal to 0. And the next one, I have to start with a positive 1. So 1 minus 1 is 0, square that is 0 times 2. Let's write this down. So I end up with 2 times 0 plus 3, that's a total of 3. Then I can plug in 2. So 2 minus 1 is 1, square root of that is 1. So I'm taking 2 times 1 plus 3, that's 2, plus 3 is 5. And then next I would go with 5. So plug in 5, 5 minus 1 is 4, the square root of that is 2. So 2 times 2 plus 3 is 7. So start at the end point, travel through, transformations, it went right 1, and went up 3. Domain, x was greater than or equal to 1, and the range was y is greater than or equal to 3. 16 and 17, we have inequalities. So on number 16, we can plug in 0, 1, and 4. Square root of 0 is 0, minus 1 is negative 1. Square root of 1 is 1, minus 1 is 0. Square root of 4 is 2, minus 1 is 1. So 0, negative 1. I actually should do an open circle here, because it's not equal to, and that's my endpoint. So open circle there. And so then I connect these with a dashed line. I need to shade below that. So I shade everything below this. Now, directly below that open circle would have been like a dashed line, because I can't actually equal that line. Number 17, I can plug in negative 3. And then I can plug in negative 2, and then I can plug in 1. When I plug in negative 3, I get 0, square root of 0 is 0. So I get negative 2. Plug in negative 2, I get 1, square root of that is 1. Subtract 2, I get negative 1. Plug in 1, I get 4, square root of that is 2. 2 minus 2 is 0. This time it can be in a closed circle. So negative 3, negative 2. Negative 2, negative 1. 1, 0. Solid line. We're shading above, so everything above that can be shaded. Number 18. Now we get into section 6-4. 4th root of 81, that's 3. 4th root of y to the 20th. 4 goes into 25 times, so I get y to the 5th. Now be careful here, that was an even root, an even power. Our result was an odd power, so I need to do absolute value around the y to the 5th. So 3 times absolute value of y to the 5th. Number 19, square root of 64 is 8. Square root of x to the 6, so 6 divided by 2 is 3. Once again, even root, even power, and our result is odd, so I need an absolute value around x to the 3rd. Number 20, 3rd root of negative 27 is negative 3. And then a, let's see, the 6 divided by 3 is 2. Don't need to worry about absolute values on an odd root. Number 21, 4th root of 16 is 2. And this is an even root, so pay attention to this. 24 divided by 4 is 6, so I get x to the 6th. Now that's an even, so I don't need to worry about absolute value there. And then with y, 8 divided by 4 is 2. That's even also, so I don't need to worry about an absolute value there either. So there are my solutions.